So in this one, we've actually seen questions like this before. What we're doing is we're trying to find the angle this time. So you'll see this, we're trying to find the angle of S. S refers to usually an angle within radians. So if sine of S, okay, that's what we're trying to find, equals 0.3210. And we want to know it's between this interval, which means it's in the first quadrant. So we've done a problem like that before, and we've talked about how you use arc sine. So you're just going to do arc sine of 0.3210, and you will put it into your calculator. I'll show you how to do that in a second in case you forgot. And you're going to get 0.326785. Again, make sure your calculators are out so you're practicing this. Otherwise, you might make mistakes later. MathExcel will tell you how many decimal places to round, so don't worry kind of about that right now, but I'll tell you more specifically within the problems. So what we've done in the past, okay, this time though we're making sure we're in radian mode, is that you're going to hit the second button first, and then you can kind of see that right there. It says arc sine. It's right above the sine, and that's how you'll plug that in, and then hit the enter button to get the value. And again, that value is 0.326785. So again, try that in your calculators. So this next question, I'll admit to you, will get a little bit tricky. So if you need to rewatch it a couple times, make sure you do that to make sure you're thinking about what's happening. This one is a very similar question to the setup. We're trying to find the angle right here, which is S. And it says the arctangent of negative square root of 3 over 3. So I'm going to approach it in the same way. I'm going to do the arctangent of square root of 3 over 3. So put that in your calculators to get a value. And what you're going to get, so pause it if you haven't gotten it yet, but what you will get is negative 0.52359 approximately. Now, that is an angle. It is an angle that will solve this equation right here. Okay, if we put it in, that will definitely give us an angle. But the problem lies with in the restrictions. It says it has to be between 3 pi over 2 and 2 pi, which is in the fourth quadrant. Okay. Now, if we think about what this is, and again, try to keep in mind that this is radians. So it's an angle measurement, but it's in radians. So if we think about that, that's a negative angle. So it's going down that way. So it is in the fourth quadrant. But the problem is that it's negative. It doesn't fit between the parameters of 3 pi over 2 and 2 pi. So what this really then sort of becomes is this becomes the reference angle here. Hold on a second, I deleted something. There we go. The reference angle, which is going to be the absolute value of that decimal. So it's 0.52. So I want to know what the positive angle is going to be. And so being within the fourth quadrant, what we normally do is we normally do 360 minus, so that should be a reference angle, right? Not the angle, minus the reference angle. But we're not using 360 anymore, we're using 2 pi. So we do 2 pi minus this 0.52359 to get our final answer. Approximately 5.7596 for our answer. And that fits the parameters of that question. So again, if you need to, pause it, rewind it so you can look back at it. This last question is going to be very similar to that. What we're going to do is we're going to find what that angle is. So we're going to use our cosine. So pause the video, go ahead and put it into your calculators. And you get this angle measurement that's in radians of 2.35619. Now, here's the problem with this one. It says it's across the interval 0 to 2 pi. So it's the entire circle. And if you think about it, that means we should have two triangles or two angles that have the exact same value. Remember how we talked about how they repeat some values sometimes. So cosine is negative. So all students take calculus or classes. And so cosine has to be within the second and the third quadrant. That 2.35 number refers to the third quadrant because pi is, nope, I'm sorry, this 2.35 refers to the second quadrant because if you think about what pi is, that's right here, that's approximately 3.14, so it's shy of that. But there's also another angle that's in here that we have to figure out. We know that one of the angles is here. So the question remains, how would you find what this angle is? I want you to pause the video for a minute or two, and I want you to think about how we could calculate that green angle based on only the information that we have in that picture. So here's what you do. I need that reference angle again. What we're going to find is we're going to find this reference angle of this triangle right here. And I'm going to do that by doing pi minus 2.35619. And that's going to come up with my reference angle. And that's going to give you 0.7854. So that means that's the same angle that's right here. And think about how you calculate that. We would now take pi plus that angle to get that angle within the third quadrant. So again, we're going to take pi and then add 0.7854. And you get 3.92, and then we'll round to 7 because there's that double 9. And so this is the angle that you find in the second quadrant. This is the angle that you find in the third. So there's two of them because it is open to all four quadrants.